Welcome, everybody. I've got permission to start. So first of all, thank you all very much for joining our webinar today. My name is Koen Hamers. I will give a short introduction about the topic of today, modern virtualization for scalability and control. I will give this webinar together with a couple of colleagues. My colleague Roel de Kort. Roel de Kort is an engineer, and of course the partners from ours, Hugo and the guys from SUSE. Like I already told you, my name is Koen Hamers. I'm country manager of Adfinis. Adfinis is an open source company. It's originally coming from Switzerland, but these days we have multiple offices in different countries around us, but also, for example, in Australia and around the globe. And the thing that we do is open source. We are really a dedicated open source company with a lot of expertise, with a lot of focus, together with 150 people these days. And what we want to do is deliver secure, sustainable, transparent IT solutions. Open source is not only a license, but it's also our own company culture. And that means that we really believe in get rid of the vendor lock-in, get control over your own data, your own secrets, your own software. And these days, we also think that the European digital sovereignty is very important. We are based in the EU, and we really are strong believers also that IT solutions these days should come also from EU. A couple of achievements that we have. One of course is the partnership with SUSE. That goes a long way back. We know SUSE almost from day one, and that's around 20 years. We have 40 SUSE certificated engineers, and we did around the globe around 60 big SUSE projects. So we know where we are talking about if we say we do SUSE. And behind otherwise than only deliver software that comes from vendors, we also really believe in that we as an open source company should also contribute to open source projects. For example, one of the key things that we're doing at this moment is drive the OpenBouw initiative. OpenBouw is a fork from HashiCorp Vault. HashiCorp decided in 2023 to close or to change their open source license. It's not open source anymore. It's a community license at this moment. So there was a fork called OpenBouw, and these days we have a couple of developers submitting full-time code and development to the open source OpenBouw project. And we deliver commercial support on top of that, so that it feels like it's our own product, although it's open source. And what we do consultancy, 24/7 operations, support, trainings. We help customers with the implementation and the maintenance of open source software. And we do that for a lot of companies, typically banks, because we are originally a Swiss company, but also a lot of ministries. Because we are very focused, bigger organizations. What will you learn today? We hope that you will learn today about how you can be independent and how you can get control of your own data completely with software based in EU, and also that falls also under EU jurisdiction. And what you will learn today is how you can seamlessly integrate the traditional VM with Kubernetes containers on a single management plane. And we will show you some couple of cases. We will share experience with you, how we do this, how other organizations do that. And we will also give you we will show you a sandbox environment that was designed for a government agency, so that you also have a little bit of technical insight. Thank you. The next, my SUSE colleagues.
Well, thank you, Koen, for the introduction. My name is Vincent Borst, and I'm the partner executive of Adfinis. So I've been working with them for quite some time now, and we did some nice projects already, like Koen explained. For those who doesn't know SUSE, think of SUSE as an original European powerhouse of open source. We were founded in Germany. We're now situated in Luxembourg, and our data rests at the European data centers. Many people know us as a Linux company, but we evolved into much more than that. We're deeply rooted in our European heritage, which means that we prioritize stability, security, and our data sovereignty. And this reliability is why the world's biggest organization trusts us. So 90% of the world leading companies trust in SUSE. This is also from what Koen said, global banks, but also hospitals, car manufacturers, but also ministries are a lot of our customers here at SUSE. So we went from Linux to cloud native. We haven't sat still. Since 2020, SUSE has transformed from a traditional Linux OS company into a cloud native leader. We did this through a series of strategic acquisitions that allows us to manage more modern IT environments from start to finish. We did that with the takeover of Rancher in 2020. And Rancher is, of course, the most popular tool for managing Kubernetes for the containers. Also, we did a takeover from Fornefactor and also StackState, which is a Dutch company. And those additions gave us top-tier security and full visibility by observability and to see how your applications are really performing. So we're talking here about the reason, the virtualization, and we do that with Harvester, which is our SUSE virtualization, how we call it nowadays. As the market looks for modern alternatives to traditional virtualization like VMware, Harvester is the answer from the SUSE side. It's the backbone of our modern infrastructure strategy, and it allows companies to run additional VMs and modern containers side by side on the same platform. So basically it means we provide an open source freedom to move away from expensive and lock-in vendors without losing the enterprise grade support that you need. And not only we're saying this, but you can see we're contributing a lot to really the open source community. As you can see on the right side of this picture, it's we're a smaller vendor than basically all the others in this row, but we're on number 3, which means that we're a little bit the underdog maybe, but we're really contributing a lot. And also, I'm gonna tell you that not only we say it, but we're being recognized by leaders as Gartner and Forrester, which places us in the leader quadrant, which already gives you an idea that we're not a small player anymore, but we're really somebody that you need to take care of and have a look at. And together with Adfinis, we do just that. And with that, I want to hand over to my colleague, Hugo.
All right, Vincent, thank you so much. I am Hugo de Vries. Nice to meet you all. I'm a solution architect in the Benelux region. And I want to talk to you more about our alternative virtualization solution. And when you take a look at the key priorities for today's organizations and CIOs, and it's with almost every customer that I speak to, they are looking to modernize more of their workloads, if not all of their workloads. They understand that the future is headed in the direction of cloud native, and that applications are going in that direction. You also see it on the top right, the quote from Gartner. where cloud-native platforms will serve as the foundation for over 95% of all new digital initiatives. So it's very clear that cloud-native is the future. But having a whole cloud-native operation, teams and tool chains running side by side to your more traditional environment, you also have the need to increase operational efficiency and to do cost optimization. So then looking at alternative ways to do virtualization, which of course were triggered by Broadcom. And to many CIOs, vendor lock-in feels like a lesson learned. And these are not my words, but these are the words from Gartner, Forbes, IDC, and more. So just to touch upon it a little bit more, the Broadcom situation. So today we're not just talking about Broadcom, we're talking about the systematic issue in digitization, so vendor lock-in. Broadcom is just the latest example of what happens when companies place their IT strategies in the hands of only a few providers. This is about sovereignty, your sovereignty. And when a US corporation like Broadcom overnight increases your virtualization cost by over 30%, they drop your partners, they dictate how you run your infrastructure. It's not just an economic issue, it's a political one. So this isn't theoretical, it's a reality, and it affects every one of us in our region. And the question is, will you accept this or will you fight back? And Broadcom really serves as a wake-up call, because one thing is clear, the next Broadcom is coming, so be prepared. So the question for you is, how much control over your IT landscape are you willing to give up? And we have the solution, and that is an open and sovereign platform, which I'd love to tell you more about. And with this platform, for instance, Deutsche Telekom has containerized over 70% of their virtual machines with Rancher into this new virtualization platform. So no lock-in, full NIS2 compliance. So why not you as well? The platform. And the foundation of the platform, the foundation of our hypervisor is, of course, the Linux operating system. It's all about absolute ownership versus proprietary risk. And especially in government and defense sectors, legal terms are as critical as the technical ones. So proprietary end-user license agreements often grant vendors the right to modify operating systems or to collect data without permission. SUSE Linux provides a sovereign alternative where the customer remains in full control, and we operate on a zero trust principle where transparency is a key element, because our builds and our test services are completely open and they can be independently audited by any nation state. And we provide you with the recipe of the software, the recipe for trust, so the software bill of materials, SALSA and LEAP, all leading to reproducible builds, preventing SolarWinds kind of scenarios, if you still remember what happened there. Everything supported with extremely long support life cycles by guaranteeing product support for 15 to 18 years on the single release. So that really makes sovereignty economically and operationally sustainable. Then on top of that Linux infrastructure and operating system, we run our cloud native stack. And also here, sovereignty is a key element. You are in full control. You can run the entire platform on your own environment, including fully air-gapped, so no dependency on an external cloud service. We have a fully verified software supply chain, so we provide a curated SUSE application collection built on SUSE Linux, which is shipping over 100 open source applications with software bill of materials, with provenance, and vulnerability scanning to support all your audits and regulatory requirements. It is enterprise-grade security by design. So we deliver hardened Kubernetes and hardened virtualization, which we'll talk more about, for regulated and for governmental use cases. And security is part of the platform. It's not an add-on. The data stays where you decide, so no forced data or metadata export. All workloads, logs, and insights remain under your jurisdiction. We provide a clear visibility into your applications, infrastructure, and your security posture, enabling you to take faster decisions and reduce blind spots. So this platform is our SUSE Rancher suite, and we will talk more about SUSE Virtualization today. As you see, underpinned by the SUSE Linux Micro operating system, with our managed by SUSE Rancher. So most organizations we work with are trying to balance three things at once. So keeping the existing workload stable, reducing operational complexity, but also creating a path to modernize when the business is ready. And if not, they try to do all these three things at once. So Kubernetes manages any CNCF certified Kubernetes distribution and manages SUSE Virtualization. So providing a single control plane for your container workloads and your virtual machines. And then SUSE Storage is a fast and scalable, cost-effective storage solution, which supports block, file, and object storage in a unified platform. And what characterizes our product suite is that it's fully composable, flexible, and that choice matters. You are in control of the components that you use in this stack. They are loosely coupled, so you decide what operating system you want to run, what security solutions you want to run. No vendor lock-in with this platform. And it is composable to different use cases. So we deliver specialized versions, for instance, for the edge, for AI observability and infrastructure, for SAP and finance. So to zoom in then a little bit more on the virtualization component, that is of course what we come here for today. And traditionally, virtualization can be very heavy and siloed. And our approach is to focus on efficiency and modernization, allowing virtual machines and containers to run on a single unified control plane. So let's take a look at the core of the stack. The base operating system, of course, is Linux, all the way at the bottom. Our SUSE Linux Micro distribution, which is an immutable, self-healing, a lightweight operating system. On that operating system, we run our Kubernetes distribution RKE2, Rancher Kubernetes Engine 2, which is a security-focused and lightweight Kubernetes distribution, making it an ideal foundation for this hyper-converged infrastructure stack. Then there is the storage layer, which is provided by SUSE Storage, and the upstream name there is called Longhorn, which is a distributed cloud-native storage solution, ensuring that your VM data is highly available, resilient, and can migrate seamlessly across different nodes in your cluster. And you can also connect external storage. So we are, for instance, certified with vendors like HPE, Portworx, Oracle, NetApp, Dell, to also make sure use of external storage solutions. Then KubeVirt. KubeVirt is key here. It is the technology that enables everything because it allows you to run virtual machines as containers in your Kubernetes cluster. So it allows Kubernetes to work with KVM, KVM, the hypervisor on the Linux OS, which has been running for over 12 years in production. So a proven virtualization technology now made accessible from Kubernetes, allowing you to manage this all through cloud-native mechanisms and methodologies. And then there is a networking stack with Multis, with kubeOVN, with kubevip, all making sure that you have a advanced networking stack with like multiple network interfaces per VM, with overlay networks, micro-segmentation, load balancing, everything is included. This whole stack is then monitored by SUSE Observability, Prometheus, or Grafana. The choice is up to you. We deliver that out of the box and managed by Rancher Prime, really the brain of the operation. It provides the single pane of glass to manage your Kubernetes clusters and your virtualization clusters across any environment. And in the architecture below you see that Rancher manages 3 underlying virtualization bare metal nodes, but this can expand to public cloud, edge, data center, and not only managing virtualization clusters, but also managing any CNCF certified Kubernetes distribution. Now, to zoom in one little step more, just to see how everything is connected, you now see here one node. We see the OS, the kernel. We see the storage, so the local storage disks, in this case, a gold tier and a bronze tier, on 2 different performance tiers. We see the Kubernetes distribution running on top of the operating system. And then we see KubeVirt on top of Kubernetes, and enabling the VMs and the containers to run on this machine. There is support for tagged and untagged network connectivity. So you see that the VMs and the containers are making use of 2 separate VLANs there at the top. Full support for VLANs and allowing you to set up isolated networks. By default, for instance, there is an isolated management network to isolate the traffic from the virtual machine network. So it's deployed on a bare metal node as one go in one ISO. So we deliver basically this stack as an appliance on a quick and easy to deploy image to do this bare metal. And because it's based on Kubernetes, we need more than a single node to run in a highly available architecture. So the second and third node will be automatically joining the cluster that the first node has created. So creating 3 control planes here, and then the cluster can grow, of course, to more nodes. And what you also see is that the clusters, or in this case, the nodes are connected with a physical network to set up a dedicated isolated storage network. And this can then also be managed by SUSE Rancher, of course, is what we've been talking about. So these 3 nodes and the whole environment managed by Rancher. There's external storage that you can connect as well. So SUSE storage is the Longhorn solution, using your local disks on the nodes to provide a storage layer. But we also support through Fiber Channel or iSCSI as a transport mechanism, using a CSI driver, because everything is extended using Kubernetes CSI drivers, to external storage arrays from NetApp, Oracle, Dell, HPE, Hitachi, Lenovo, you name it. So this is again, the Harvester UI also integrated in the Rancher UI. So as a user, you will experience this as one integrated solution. And because it's running and using Kubernetes as the scheduler and orchestrator, we also make use and leverage all the high availability and control loops and mechanisms that Kubernetes has built in. So meaning you can apply a readiness check to a virtual machine to check if a certain service is running or not. If not, we can automatically, or the VM automatically gets redeployed on a healthy node, or when one of the nodes fails, all the VMs automatically get restarted on a healthy node. And also then that is going via the same principle for storage. So Longhorn, SUSE storage, is running by default 3 replicas of your data. So on the node itself, but also on 2 other nodes. And as soon as there is a failure, or you do a live migration, your VM is moving to the other node, and it's picking up where it was before in a seamless manner. Then I've talked about Rancher managing the environment, managing Kubernetes clusters, managing SUSE virtualization clusters. As you see, it connects to a public cloud environment as well, where it is able then to use these public cloud environments as infrastructure providers. So spin up an AKS cluster, spin up an EKS cluster, spin up a GKE cluster, all natively integrated in Rancher, but also working directly with virtual machines on the different hyperscalers, all possible from within Rancher in the same environment and in the same way how you are managing SUSE virtualization clusters and Kubernetes clusters that you are running yourself in your own data centers or on the edge. And what is a truly unique thing is that Rancher is providing this governance layer, this governance model over your whole environment, because you integrate Rancher with your identity access management solution, and then everybody is accessing these clusters and these infrastructure providers via Rancher, so automatically secured via the RBAC model, the robust access control model that is inside Rancher. So very powerful to stay in control of a very big environment. And that goes for virtual machines and containers alongside each other. Now, I know that a lot of people have joined this webinar because they are using VMware and they are looking for alternatives. So we are not a one-on-one replacement. There's no one-on-one migration script to migrate everything over from VMware to SUSE virtualization. But all the core concepts that you see in the middle of these slides, they are all addressed in solutions on the SUSE virtualization platform and in the world of cloud native. So if we are not doing it ourselves, there are other tools out there that are able to do it. And again, on the right side, there is choice here to fill in these pieces of functionality by the solution of your choice. That is the beauty of open source and cloud native. So lots of standards everywhere. Instead of proprietary communities and proprietary standards behind logins, everybody is working according to the same standards and via the same philosophies. So really making it very powerful to modernize towards here. So a little bit on this migration. This is not a product to migrate from VMware to SUSE virtualization. It really is a project and a shift in mentality. And the virtual machines, they will migrate very simply via a tool. And via the virtual machines, migrating them, that is simply not the only thing. The platform needs to be re-platformed. So the whole the hardware that you are currently using for VMware can be reused for SUSE virtualization. So that needs to be redeployed and reinstalled. And then where the biggest changes will be for the skills, processes of the people who are now doing the operation, the automation, and the integration of this environment, because that on SUSE virtualization all works in a cloud native manner, and of course the proprietary tools that you've been using on the VMware estate do not work on SUSE virtualization. So there will be some things that you will be doing in a different way, but this provides, like we said, huge opportunity because the world is moving towards cloud native. Cloud native is proven to be the future. So you better catch up, and it provides a great opportunity for the administrators of the VMware platform to join forces with your cloud native platform team, use their knowledge to make sure that these machines are running smoothly on a new platform and that the integration is set up properly. So then when you migrate, and let me looking at the platform, it is about compute. Of course, you reuse your existing hardware towards SUSE virtualization. You can migrate your storage. So going from vSAN to Longhorn, the migrating the storage volumes is something that needs to happen. Or you do not migrate it to Longhorn, but you migrate to an external storage, and then you leverage the CSI driver, like I mentioned, to connect via fiber channel and iSCSI to a network storage array. And then the network needs to be migrated and transformed as well. Or in a lot of cases, you reuse, of course, your existing VLANs and that setup. And it's a matter of connecting SUSE virtualization to those same networks, do your network migration. Now, to top it off, I just want to show you a quick example of a typical deployment here, in this case of VMware, where we see 3 hypervisor nodes, 3 ESXi hypervisors with VMs on it. They are connected to 2 different VLANs, and they are managed by vCenter, and then physically connected to 3 networks. So there's the vMotion network, the storage network, and the management network. Now, we are taking one of these machines and we are deploying SUSE virtualization on it. So one of these machines will be added. It will be connected via the Linux bridges to the same VLANs. So the connectivity is then immediately the same. And it will also connect to a live migration network, a storage network, which is our Longhorn network, an API network, and these can all be connected and bridged. But this is up to the choice of your network engineers. And this SUSE virtualization instance is managed by Rancher. Then you migrate over the virtual machines using import script. And an import tool is what we call the VMImport controller. And then because SUSE virtualization scales very nicely horizontally, you add a second node, the same story, and then you move over virtual machines once more. So it can happen in side by side in parallel, this migration of your existing environment. No need to go over with one big boom. And yeah, this is how a typical deployment then looks like. And to show this, how this looks in action, I would like to give the word over to Roel from Adfinis.
Yes, thanks Hugo for the lowdown of the virtualization stack. As Koen mentioned at the beginning, my name is Roel de Kort. I'm a DevOps engineer at Adfinis, and I'll be connecting the theoretical part that we just discussed into something tangible. I'll be providing a demo setup, showcasing how it all ties together. So for the foundation, the architecture for this demo, we have the foundation harvester, which will host the virtualization part, Rancher as the management plane, and for the automation part, we will be showcasing Argo CD. For the demo environment, we have the stack currently running in Hetzner Cloud, which consists of 3 harvester nodes. Where we already have configured a couple of systems. We have a VM running a K3s with Argo CD that is connected to a GitLab repository. We also have a Rancher cluster running, which is connected to Harvester. So for the next part, I'll be stopping this. So Hugo already showed in one of the slides the harvester UI. So that is what we currently are seeing. This is the management view, which can be a little bit comparable to ESXi. Where we have a overview of the different hosts, the amount of virtual machines that are currently running, the virtual networks, images, volumes, disks. So as I already mentioned, we have a couple of systems already running, which we can see on this view. And the beautiful part is it's a collection of different open source components. So Harvester also provides different add-ons. So for example, we have the Grafana monitoring add-on, which out of the box provides you a monitoring view of your virtualization stack with built-in dashboards that will help you as an SRE give insights in the platform itself. So we have different virtual machines running. The beautiful thing is it also supports Windows servers and Windows VMs. So for example, I've deployed a Windows server here. Can take it over with VNC. And actually, this is pretty cool because we have a Windows system running on top of Kubernetes. If we go over to this side, on top of on Harvester, the virtualization part is actually KubeVirt, which is also an open source solution. So what we can do is I'm connected to the Harvester cluster. And what we actually can do is get the different virtual machines that are running on the system. And what we can see is we have the different virtual machines running. Which actually, the Windows server in this case is a KubeVirt virtual machine CRD, which you can manage through this. Going back to this view, let me close this one up. So this is actually then the virtualization layer. If we then go a level up and to the management plane, which is Rancher in this case, which is the multi-cloud management plane on which we can either manage or provision different clusters, either on Harvester or different cloud providers. And due to the integration that it has with Harvester, we have also an integrated view from Rancher into the one or more Harvester clusters that you have under management. So from here, we can actually go directly from Rancher into the Harvester UI. So you don't actually have to go to the Harvester UI itself. So for this demo setup, I'll be showcasing a cluster creation using ClickOps style. But it's also possible to provision your downstream clusters that you manage through Rancher using either Argo CD or using Terraform. But for this showcase, I'll be showing the ClickOps part. So as I already mentioned, we have different providers on which we can provision different Kubernetes clusters. And in this case, we're going to be using the Harvester provider, which allows us to automatically provision downstream Kubernetes clusters on Harvester. So we'll be providing a name in this case, SUSE webinar. We can give it a pool. So this allows us to automatically assign the amount of nodes that you want in your cluster. And you can also give them or separate them out in different roles. For this demo, we're going to keep it small. We're just going to be using a single node cluster. We provide it in the demo or in the default namespace. Give it a SSH username. We already provisioned Harvester with different images. In this case, we'll be using the Ubuntu 24.04 image. We have to assign it to a network that we also provisioned. And we also have the option and possibility to do some advanced configuration. So we have the ability to choose the Kubernetes distribution that you want to use, either RKE2 or K3S. For this demo, we'll be using the K3S distribution. And if you so choose to, have multiple different ways that you can make a more production-graded Kubernetes cluster. But for this case, we'll be only showcasing the provisioning part of K3S in a single node setup. So we have the basic configuration done. We'll be starting the creation setup. What we now see is that it's registered inside of Rancher. And now if we go to Harvester itself, go to virtual machines, we actually would see, that's popping up. So due to the connection that Rancher has with Harvester, it can provision the virtual machine. It will spin it up, and using a cloud init configuration, it will actually automatically provision it with K3s and then register it back into Rancher. So we'll let this cook for a bit and move on to the next part, and that is actually the automation piece of the demonstration. So what we already provided there was the Rancher cluster, which we actually already deployed using. Oh, and I'm logged out. That's not good. One moment. This is also inside of VPN, so. And we're back. That's the beautiful part of live demos. We already deployed the Rancher cluster using Argo CD with a custom Helm chart. But that's all nice and dandy. Let's deploy a new VM using Argo CD on top of Harvester. So I already prepared some stuff beforehand. So we have a custom Helm chart that allows us to deploy a virtual machine or multiple virtual machines on top of Harvester. So what we did is we applied the application set manifest in Argo CD. So if we move back, we actually see that the application is currently processing. What it actually does, it deploys the virtual machine. It deploys also a cloud init file that, in our case, configures the networking part. So it sets the MTU because that's necessary in Hetzner. It creates the virtual machine instance, and at the end, it creates the pod that actually runs the VM. And if we actually then move back to Harvester, we see the Linux VM that we just deployed that is currently booting up. And that's actually the beautiful part, is that you can use cloud native tooling to deploy traditional virtual machines, either Linux or Windows. If we now go back to Rancher, hopefully we should see that it's done. Not yet. Almost. So it's currently going to join Rancher, and after a while it will go into active state. And from this we then have the downstream cluster under full management. So we see it popping up here.
And meanwhile, sorry to interrupt, Roel, we have 14 questions in total. So
I think we're also finished with the demonstration part. So what we actually saw is the SUSE webinar downstream cluster running K3s is correctly provisioned now and under management of Rancher. So I think if we go to this one, we can go to the questions.
Well, thank you for the perfect timing, Roel, and thank you for providing us this information. Yeah, like I already said, we've got 14 questions. I think
see quite a few that I can answer, so I can just start.
Yeah, perfect. Yeah.
So Michael was the first one to come in with a question. Is it mandatory to use Longhorn? So Longhorn is always used, but at the minimum it's used to store the configuration of SUSE virtualization and to store the images. And You do not need to mandatory use it for the data volumes for the VMs itself. You can use external storage for that as well. So it's not mandatory to use it for your external data volumes, but it comes as part of the stack. Then Olivier, he asked, what about scaling? We often hear that KubeVirt is to run a few VMs that cannot be migrated to cloud native. I don't really understand the question. The solution scales very well horizontally and automatically if you add more nodes. So if you can clarify your question in the chat, that would be great. In the meantime, I'll continue to another one. Dirk, you asked, is Pure Storage also supported? And it is, yes. Portworx and Pure Storage both supported as external storage for SUSE virtualization. Then Jurgen, you asked, can CheckMK monitor the complete stack? So we provide you with the Prometheus endpoints with the metrics. So CheckMK, I know, also is able to integrate data from Prometheus. So using that mechanism, you can then indeed also get all these metrics into your CheckMK environment. Question from Benjamin, is there any special agreement with Oracle regarding their ways of licensing workloads using Oracle databases and middleware, like on AIX, iParse? So the virtualization technology here is KubeVirt, and in some cases, and the most prominent example of that is SAP HANA, which SAP does not certify to be ran on any form of KubeVirt-based virtualization. So then SAP HANA is not supported. For Oracle, most products are supported. So check which product you're looking for and check the requirements. I do know of Oracle databases that are running on KubeVirt-based virtualization. So, question from Jimmy van der Mast. He asked, what about traditional Windows Server VMs with traditional applications? And luckily, Roel, you showed them that. The only thing that you need to run Windows VMs and to be able to use the storage is to deploy the VirtIO driver in your Windows instance. You can also do this during the installation when selecting the installation target of the Windows installer. And then you could also perfectly run Windows on this environment next to Linux and your Kubernetes nodes. And then another question from Dirk. SUSE virtualization was never positioned as a replacement, only as a way to run a few VMs alongside your containerized applications, and specifically for workloads that couldn't be containerized in the short or long term. What changed that SUSE virtualization is now positioning as a replacer? Yeah, that's right. We were very cautious indeed last year. But in the meantime, customers of ours simply ignored us and went for the migration. I mentioned Deutsche Telekom migrating 70% of all their VMs to SUSE virtualization. And then the remainder of the VMs can be ran on KVM-based hypervisors. They're directly on the Linux operating system. So we simply see that customers are doing it and that it's working fine. And also, Broadcom gets more aggressive towards its base and towards its partners. So the urgency simply has become higher. We are not a one-on-one replacement. It is quite a change to move to cloud native technology, but it definitely is possible. Mark asks, is there some kind of tutorial to set up my own cluster in Hetzner? And can it be done without a license? So I can answer that it can be done without a license because using Harvester, the hypervisor, the upstream name of this project, and Longhorn, SUSE Storage, all is possible, completely open source. So you can definitely use those software. But maybe you, Roel, can share a little bit more on if there are some guides available to deploy this on Hetzner, and maybe how did you do it?
Not readily available, so we had to do some own research, but I think we can look into to see what we can provide in that case for that.
Okay.
See if we can do a write-up to deploy a small scale deployment on Hetzner Cloud or Hetzner Robot actually.
Right. Then a question from Dirk. Can you import YAML files into the system where the VM configuration is written outside of the cluster and are outside of Rancher? And yes, that is the whole beauty of Cloud Native. You absolutely can. Everything here are Kubernetes objects. So the virtual machines are CRDs. Everything is defined by YAML manifests. So you can definitely define your virtual machine templates in an external Git repository. As soon as a change is made to that Git repository, the machine will be redeployed according to those specifications, for instance. So yeah, that is actually the whole idea of managing things in a cloud native way. You can definitely do that. Then question from Pavle. Does the harvester run containers or Rancher Kubernetes cluster is running over harvester and then the containers are ran in that cluster? The answer is it's everything. So you can decide to deploy containers, basically bare metal, on the RKE2 cluster that comes as the virtualization layer. You can do that in some cases when high performance is key. But in most cases, you create virtual machines on top of the hypervisor, and you use that as nodes of a Kubernetes cluster, and you deploy your containers in those Kubernetes clusters. Everything is supported, but we support a combination of all those different solutions. So container directly on the virtualization host and containers ran on a virtual machine in a podman. You can also do that, or you run your container as part of a Kubernetes cluster, which the nodes are provisioned on this harvester virtualization. So yeah, you can do it in any flavor that you like. Dirk, you also asked, is there an availability utility for migrating VMs from VMware to Harvester? Yeah, we use the VMImport controller, and what that does for you, it creates the YAML manifests to perform the migration. So it connects, for instance, to vSphere. It reads the network configuration, does the network configuration mapping in a YAML manifest. It does the resource requirements, which are then specified in the YAML manifest, and then the rest of the machine definition also in the YAML fest, and then the VM is imported. So yeah, we use the VMImport controller for that. And then the point was, Olivier has a question: how many VMs can we run? Today we have about 1,500 VMs. Yeah, that is totally fine. So you can run up to 254 cores per node, and then the nodes scale horizontally. So you can definitely deploy 1,500 VMs on this environment, no problem. Question from Rachel: is Fujitsu supported as external storage? And I believe it is. The beauty is we are leveraging the Kubernetes CSI drivers for this integration. And people have been working on integrating external storage solutions in Kubernetes as long as those CSI drivers exist. So they are not working on specific integrations, or they need to work on specific integrations to search virtualization. As long as they are releasing a CSI driver for their storage platform, and for Fujitsu, there are CSI drivers available. You can use it, but the CSI driver needs to support a couple of features like read-write many. That's for multiple nodes to be able to connect to the same volume so that we can perform a live migration. And there are three other points that the CSI driver needs to support, like volume ballooning. You provision a volume very small. After it's provisioned, you balloon it up to big size. So a couple of features, and they are part of our requirements, which the CSI driver needs to support. And then it should work with SUSE Rancher. And we have quite a list of supported storage solutions already, which we then have certified and validated.
I think Femi also has a question about Postgres DB clusters on this environment. I think it can be done on multiple ways. You can provision a VM-based Postgres cluster. But if you want to go more cloud native, you can go to cloud native Postgres, for example. So I think there are multiple ways on how to configure and manage Postgres clusters. Regarding the snapshot question, it also supports snapshotting via virtual machine snapshotting. Hope that answers your question.
Yes. And then a question from Erik.
Thomas.
How does Rancher Harvester handle the lifecycle management of the underlying Node OS? And is SUSE Manager needed to support Harvester based on SUSE Micro? Well, the SUSE Micro, as part of the hypervisor, that comes basically as an appliance. So there's no need for you to manage that instance. That will simply be updated with every new version of Harvester, our SUSE Virtualization that we bring out. For the operating systems that you run and bootstrap as VMs to serve as virtualization nodes in your environment, as Kubernetes nodes, we have Elemental, which is built into Rancher. And Elemental is basically the operating system manager, which is creating images based on SUSE Linux Micro, and then bootstrapping RKE2 with the right configuration onto that OS. And then Rancher does take care of the lifecycle management of all those VMs. So it will drain nodes of any workloads which run on top of it. It will update the node, and after the update is successful, it joins the cluster again, and workloads will be migrated back to that node, all completely automatically taken care of for you.
I think Thomas also has a question.
I think maybe the last question there.
Yeah. How does moving to SUSE solve the vendor lock-in issue? I think we'll also showcase it's SUSE, it's SUSE Harvester, but underneath it's the open source component. So it's KubeVirt, it's what I also showed Grafana. It consists of all open source solutions. So if you want, you don't even have to use the SUSE solution, but you can use straight up KubeVirt or the other tooling that are provided.
I think if you use a closed source license, then you are not allowed to use the software anymore. And that's something that you don't have if you use open source license. If you don't continue with the license agreement or the subscription, you still are able to use the software.
Yeah. And you are able to move to other virtualization solutions as well, free to do that. That is indeed what describes not having the lock-in. Then maybe one or two final questions before we are out of time. So Frank asked, what about backup and recovery solutions like Veeam and Commvault? So the backup and recovery solutions that are able to work here with SUSE Virtualization, they typically fall into two categories. They're either Velero based, the open source backup and recovery solution for Kubernetes, by default, fully command line based. So solutions that build a nice UI around that and use Velero as the technology. And then you have players like Veeam Custom and Portworx who have created their own integration mechanisms to do this backup and disaster recovery, where you're then able, for instance, to target very specific workloads and not the whole data volume or the whole volume of the VM itself. So yes, Veeam Custom is supported. Portworx is supported. Veritas. And so yeah, those storage solutions definitely are working on SUSE virtualization. Right, and then I think we ran out of time.
Yes,
Great
thank you very
questions.
much. Yeah, we still have questions about the licensing. How's the licensing cost calculated for SUSE virtualization? But that's also something that we can also answer in a mail. So we will pick that up and send the mail. And it also counts for the other open questions. We will answer everything, maybe not then in this live session, but we will do it via mail. So I really would like to thank everybody, our own Sam for making this all possible, and of course Hugo and Roel and Vincent and everybody else, and my colleague Annabelle for making this possible. And feel free to contact us if you've got any questions. Also, if you say, well, I'm interested, please come to our office and give us a live demo. That's more on topic of our own situation. Please contact us, and thank you everybody, and I hope to see you soon. Bye bye.
Bye bye.